Hey guys, this week we are going to be talking about midpoint and distance formulas. These are two important formulas that we're going to use throughout geometry. So this isn't just a one-time lesson. We'll definitely refer back to these later on in the year. So the first thing is the midpoint of a segment. It's the point that divides the segment into two congruent segments, or two congruent pieces basically. So it's like taking a ruler and cutting it in half, and then you have two congruent pieces. Then a segment bisector is a point, array, line segment, or plane that intersects the segment at its midpoint. So the midpoint is a specific point, just like when we're talking about point A, point B, stuff like that. The midpoint of a segment bisector bisects a segment. And bisect means to cut in half into two congruent pieces. So if you look at this first figure here, we have segment AB, and then point M is directly in the middle. Point M is the midpoint of segment AB. And what this does is it means that AM, segment AM, is congruent. We got that weird equal sign with the squiggle over it, to MB, and then it tells us that the distance from AM is equal to the distance from M to B. Okay, so notice the difference between these two equations here. One has an equal sign, one has a congruent sign. Okay, on the other side we have CD is a segment bisector of AB. That is line CD. It has the two arrows, but it goes through point M, so technically that is a segment bisector, and it does the exact same thing. It cuts those two pieces into two congruent parts. Now, how do we actually calculate the midpoint? So when we calculate the midpoint, if you look at the first thing, it says x1 plus x2 divided by 2, y1 plus y2 divided by 2. What we are doing is we are looking at coordinate points. So we are adding up two x value coordinate points and dividing by 2. This is the average of the x's, and this is the average of the y's. So this is how I like to think about midpoint. Basically, you're just taking two things, cutting them in half, and you're finding their middle point. So now how we do this with A and B down here, 4, 3, and 7, negative 1, is we go ahead and label these. So this is my x1, y1, because it's a coordinate pair, and then my second set is x2, y2. So now I just want to focus on my x's first. So my formula up here, I add them together. So 4 plus 7 divided by 2. And I'll put a comma. And now I want to focus on my y's. I'll do a different color here. So y1 and y2. I have to be a little careful because I'm working with a negative. So I'm taking 3 plus negative 1, dividing that in half. 4 plus 7 is going to give us 11 over 2. That's the left-hand side. And then 3 plus negative 1. When you add a negative, that's like subtracting. So we get 2 over 2. And then we just simplify these. You could leave your answer right there as 11 over 2 or 2 over 2. But if you type in 11 over 2, you get 5.5, and 2 over 2 is 1. That's the simplified version of what we want. And that's our midpoint. It's really not too bad. You're just finding that average, adding two things together, and dividing by 2. Distance requires a little bit more work. So when we're calculating distance, we are finding the distance, like the actual measurement between 2 points, whether that's in inches, centimeters, units. Typically, we're talking about units because this is on a coordinate grid when we're talking about coordinates. So we want to find the length of AB. We're using those same points. So just like last time, let's go ahead and label these out. So this is my x1, y1, x2, y2. This is just a good habit to get into. It'll save you some time when you're setting it up. So D equals the square root x2. So now x2 is 7 in this example, and x1 is 4. So we're taking 7 minus 4, and we are squaring that. Then we are adding the difference in our y's. So y2 is negative 1. y1 is 3, and we're subtracting those and squaring that. Remember to follow the order of operations when you're doing this. So PEMDAS, what comes first is what's inside the parentheses. P stands for parentheses. So 7 minus 4 gives us 3. We still need to square that. And then negative 1 minus 3 is going to give us negative 4. Then we have to square that. Now, PEMDAS, and then it is exponents. So the next thing we need to do before we take the square root of all of this is we need to take 3 and square it. So we get 9. 3 squared is 9, and negative 4 squared is actually positive 16. Whenever you're doing this, you should always get positive numbers inside, so we end up getting positive 9 plus positive 16, because when you square a negative number, it becomes positive. Then we need to add what's inside, 9 plus 16, which gives us 25, and the square root of 25 is 5. So the distance from A to B is 5, and that would be in units, technically. All right, so the last, or one of the last examples here, excuse me. The endpoints of RS are 1, negative 3, and S is 4, 2. We want to find the coordinates of the midpoint. Okay, so the endpoints of RS are 1, negative 3, and 4, 2. So I'm going to label this my x1, y1, x2, y2. So we just want to find the coordinates of the midpoint. So I'm going to go ahead and add these. Remember, my formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So 1 plus 4 for my x's, and then negative 3 plus 2 on the other side. 1 plus 4 gives me 5. Negative 3 plus 2 gives me negative 1 over 2. And then when I simplify this, I get 2.5, negative 0.5, or negative 1/2. You're welcome to leave it as a fraction, or you can put it in the decimal form. Either one would work for me. Okay, and then this last one, I just want you to attempt on your own and then submit your notes back. So that is all I have for these.